Thank you for click on this video. I sajal.sasmal welcome you to complete lecture series of solar photovoltaics. Please click on description for playlist of complete solar cell tutorial. Let's start. Intrinsic carrier concentration. Intrinsic carriers are the electrons and holes that participate in conduction. The concentration of these carriers is contingent upon the temperature and band gap of the material, thus affecting a material's conductivity. Knowledge of intrinsic carrier concentration is linked to our understanding of solar cell efficiency, and how to maximize it. The thermal excitation of a carrier from the valence band to the conduction band creates free carriers in both bands. The concentration of these carriers is called the intrinsic carrier concentration, denoted by Ni. Semiconductor material which has not had impurities added to it in order to change the carrier concentrations is called intrinsic material. The intrinsic carrier concentration is the number of electrons in the conduction band or the number of holes in the valence band in intrinsic material. This number of carriers depends on the band gap of the material and on the temperature of the material. A large band gap will make it more difficult for a carrier to be thermally excited across the band gap, and therefore the intrinsic carrier concentration is lower in higher band gap materials. Alternatively, increasing the temperature makes it more likely that an electron will be excited into the conduction band, which will increase the intrinsic carrier concentration. This translates directly to solar cell efficiency. Intrinsic carrier concentration in a semiconductor at two temperatures. In both cases, the number of electrons and the number of holes is equal. Undoped silicon intrinsic is rarely used in the electronics industry. It is almost always doped for device fabrication. Intrinsic carrier concentration of silicon as a function of temperature. The exact value of the intrinsic carrier concentration in silicon has been extensively studied due to its importance in modeling. At 300 K, the generally accepted value for the intrinsic carrier concentration of silicon, Ni, is 9.65 times 10 to the 9 cm3 as measured by Altermat, which is an update to the previously accepted value given by Sproul. A formula for the intrinsic carrier concentration in silicon as a function of temperature is given by Misiakos. The small difference in the values of Altermat and Misiakos is within the bounds of experimental error. While the intrinsic carrier concentration is normally quoted at 300 K, solar cells are usually measured at 25 degrees Celsius where the intrinsic carrier concentration is 8.3 times 10 to the 9 cm3. Thank you for watching the video. Please like and share this video. I will be so happy if you subscribe my YouTube channel. Click on description for playlist of complete solar cell tutorial.